The universe does not owe us comfort. We like to imagine space as silent, distant, indifferent, a black canvas dotted with pinpricks of light, far enough away to feel safe. But the deeper we look, the more we realize that the cosmos is not silent. It hums. It flickers. It sends us things we cannot explain, and then, just as quickly, it takes them back. I am Cosmic Wanderer, and I have spent longer than you can imagine watching light travel across the dark. Tonight, I want to tell you about the things we have found out there that we still do not understand. Not myths. Not fiction. Real recordings, real data, real anomalies sitting in the archives of observatories around the world, waiting for someone braver than comfortable to ask what they mean. Let's begin with a single moment. August 15, 1977. A radio telescope in Ohio, nicknamed Big Ear, was scanning the sky automatically, searching for patterns that didn't belong, the kind of signal you might expect if something out there were trying to say hello. On that night, for exactly 72 seconds, it found one. The signal was strong. Unusually strong, 30 times louder than the background noise of the universe. It arrived at almost exactly the frequency scientists had predicted an intelligent civilization might use to broadcast across the stars, a frequency tied to the natural vibration of hydrogen, the most common element in existence. It rose, peaked, and faded in a smooth curve, exactly the shape you'd expect from something entering and leaving the telescope's field of view as the Earth rotated beneath the sky, not from a passing satellite, not from noise, not from anything we've ever managed to identify at that spot again. The astronomer on duty, a man named Jerry Emin, circled the printout in red pen and wrote a single word beside it: wow. That name stuck. The wow signal has never repeated. Astronomers have pointed telescopes at that same patch of sky in the constellation Sagittarius again and again, for decades, hoping to catch it a second time. Nothing. Not a whisper. Some have proposed it came from a comet passing through, but the chemistry doesn't quite match, and the timing has never lined up cleanly with any known object. Others still believe it may have been the first, and possibly the only, message we have ever received from something not of this Earth. Here is what unsettles me most about it. It's not that we don't know what sent it. It's that we know exactly how rare it would have to be for a signal like that to reach us at all. Decades of listening, and only once, for 72 seconds, did the universe seem to speak in our direction. And then it stopped. As if a door had opened just wide enough for us to notice it existed, and then closed before we could see what was on the other side. Some of you are already telling yourselves a comfortable story, a satellite glint, a rare astrophysical fluke, a coincidence of geometry. Perhaps. I won't take that comfort from you. But I will ask you to sit with the alternative for just a moment, the way I have sat with it for far longer than 72 seconds, that somewhere out there, something noticed us too, if only once, if only for a breath, and then went quiet again. Space is full of moments like this, flashes of information that arrive without an explanation attached, daring us to decide whether they are noise or meaning. Tonight, I have gathered 4 more. Each one is documented. Each one is real. And each one, in its own way, is more disturbing than the last, not because it threatens us, but because it reminds us how little of the dark we've actually mapped. Let's keep going. The universe isn't finished whispering yet. I want you to imagine something that should not be possible, a sound so low, so impossibly deep, that it takes 250 million years to complete a single note. Not 250 million years to travel somewhere. To complete one wave of the note itself. This is not poetry. This is measured, published, peer-reviewed fact, discovered by NASA's Chandra X-ray Observatory in a galaxy cluster called Perseus, roughly 250 million light-years from where you're sitting right now. At the center of the Perseus cluster sits a supermassive black hole, one of the largest known, and around it, an enormous cloud of superheated gas fills the space between galaxies. When astronomers examined ripples in that gas using X-ray imaging, they found something extraordinary. Sound waves, real pressure waves moving through the gas exactly the way sound moves through air, radiating outward from the black hole in perfect, rhythmic pulses. They translated the pitch. It came out as a B-flat, 57 octaves below middle C. To put that into something your ears could survive, scientists had to raise the pitch by 57 octaves, quadrillions of times higher than its true frequency, just to make it audible to a human ear for a few seconds. What you'd hear, if you could actually stand in that gas cloud and listen at the real pitch, is nothing, because the wavelength of that note is longer than most galaxies. Your entire body, your entire planet, your entire solar system would fit inside less than a single wavelength of that black hole's voice. This isn't the only sound we've found where none should exist. In 2022, NASA released a sonification of the same cluster that made headlines, not because the physics was new, but because for the first time, people could actually hear it, this deep, groaning, alien tone rolling outward from something so massive it bends the fabric of space around itself. Listeners described it as unsettling in a way they couldn't articulate. I don't think that reaction was irrational. I think some part of us recognizes, on an instinctive level, that we are hearing something that was never meant for ears, a byproduct of gravity so extreme that it makes the space around it ring like a bell, forever, in a note too vast for any living thing to perceive. And Perseus is not alone. Black holes across the universe have been caught doing things that sound less like astrophysics and more like folklore. In 2023, astronomers observed a black hole that appeared to burp, flaring violently years after consuming a star, as though the star's remains had been sitting undigested before suddenly, inexplicably, being expelled in a burst of radiation. Other black holes have been caught apparently waking up after decades of silence, brightening without warning, for reasons we still can't fully model. Here's what disturbs me about the sound in Perseus specifically. It's not the pitch, and it's not the impossible timescale. It's what it implies, that black holes, the objects we've spent decades treating as silent voids that simply consume and vanish, are not silent at all. They resonate. They generate motion in everything around them on a scale so enormous that sound becomes a technically accurate word for what is, in every sense, closer to a heartbeat than an explosion. We built our entire intuition about black holes around darkness and silence, an absence, a nothing, a hole where information disappears. But what the Perseus cluster tells us is that even in the deepest, coldest, most crushing environment we know of, matter still moves, still ripples, still, in its own impossibly slow way, sings. I find that more unsettling than any monster from fiction. A monster you can fight. A resonance that has been playing the same impossibly deep note since before our sun existed, and will likely keep playing it long after, that is something else entirely. That is the universe reminding you that scale does not care about your comfort, and time does not care about your lifespan. Let's move from sound to sight, because the next mystery isn't something we heard. It's something we watched disappear. In 2015, a citizen science project called Planet Hunters flagged something odd about a star roughly 1,470 light-years away, officially named KIC 846-2852. Most people just call it Tabby's star, after Tabitha Boyajian, the astronomer who led the team that first tried to make sense of it. Stars flicker. That's normal while planets pass in front of them, dimming their light by a tiny, predictable, repeating fraction of a percent, which is exactly how we've discovered thousands of exoplanets. Tabby's star did something else entirely. Its light dropped by up to 22%, an enormous, irregular dimming that didn't repeat on any clean schedule, didn't match the signature of a planet, and didn't match any natural phenomenon astronomers had previously catalogued. For context, for a planet the size of Jupiter to block that much light from a star, it would need to be almost impossibly, unrealistically large relative to its star. Nothing we know of should be able to block over a fifth of a star's total output and then simply move on without a clean, periodic return. The scientific community reacted the way it should, with caution, and with dozens of competing theories. A shattered comet fragmenting into an unusually dense field of dust. A swarm of asteroids caught mid-collision. An uneven, patchy disk of debris left over from planet formation, tilted just right to slice unevenly across our line of sight. But one theory, floated cautiously and half-seriously by a few astronomers including Jason Wright at Penn State, refused to fully go away. What if the light wasn't being blocked by natural debris at all, but by something built, an enormous megastructure, potentially something like a partial Dyson swarm, a hypothetical technology in which a civilization surrounds its star with structures to capture its energy? I want to be honest with you about where the evidence actually landed, because I think the truth is almost as strange as the speculation. Follow-up studies using different wavelengths of light found that the dimming affected blue light more than red light, a pattern consistent with dust, not with a solid opaque object like a structure or a fleet of ships, which would block all wavelengths equally. Most astronomers now lean toward an explanation involving an unusually thick, uneven cloud of dust, possibly from a disintegrated planet, moon, or comet swarm, drifting in a way we haven't fully modeled yet. And yet, most astronomers lean toward is not the same as we know. Even the dust explanation requires an amount and configuration of debris that pushes the edges of what we've observed anywhere else in the galaxy. Tabby's star remains, officially, unusual enough that it's still being monitored, still being studied, still occasionally showing dimming events that don't perfectly fit the models built to explain the earlier ones. Here's the part that stays with me. For a brief window, one of the most rigorous, skeptical, peer-reviewed scientific communities on Earth looked at real data and said, out loud, in published papers, we cannot yet rule out an artificial explanation. Not because anyone wanted headlines. Because the natural explanations, for a while, genuinely didn't fit well enough to close the case. That's rarer than people realize. Most strange signals get explained quickly and quietly. Tabby's star took years to even partially explain, and even now the explanation carries an asterisk. Somewhere in a disk of dust, or perhaps in something we still haven't correctly modeled, a star more than 1,400 light-years away dimmed by nearly a quarter of its total light, more than once, in a pattern nothing else in the sky has quite matched. Maybe it's dust. Statistically, it probably is dust. But probably is not the same word as certainly, and in a universe this large, I've learned to respect the distance between those two words. Now let's talk about something far larger than a single star, something so massive it is quietly dragging our entire galaxy toward it, and that we can't even see directly. There is something out there pulling on us. Not metaphorically. Not poetically. Measurably, physically, right now, and we cannot see what it is. In the 1970s and 80s, astronomers mapping the motion of galaxies noticed something strange. Our galaxy, the Milky Way, along with our entire local group of galaxies, and thousands of other galaxies across a region hundreds of millions of light-years wide, are all moving in the same direction, at roughly 1.4 million miles per hour, toward a single point in the sky. They called it the Great Attractor. The unsettling part isn't the speed, though that alone is difficult to comprehend, fast enough to cross the distance from New York to London in about 6 seconds. The unsettling part is that the point everything is falling towards sits directly behind the crowded, dust-choked center of our own galaxy, in a region called the Zone of Avoidance, where our view is almost completely blocked by the Milky Way's own stars, gas, and dust. We are being pulled, with tremendous, consistent force, towards something we structurally cannot look directly at. Using X-ray observations and radio telescopes that can partially see through galactic dust, astronomers eventually identified that the Great Attractor sits near the heart of a supercluster of galaxies called Laniakea, Hawaiian for immense heaven, a structure so vast it contains roughly 100,000 galaxies and stretches over 500 million light-years across. Our entire galaxy is just one small part of Laniakea's outer edge, drawn slowly, inevitably, toward its gravitational center. But identifying Laniakea didn't fully solve the mystery, because when astronomers measured the total mass they could account for in that region, it wasn't nearly enough to explain the strength of the pull. And as if that weren't strange enough, in the 1990s a second, even larger anomaly was discovered layered underneath it, an enormous dark flow, a bulk motion of galaxy clusters moving in a consistent direction that couldn't be explained by any visible structure at all, as though something even larger, possibly outside our observable universe entirely. We're tugging at the fabric of everything we can see from beyond its edge. Sit with that for a moment. We are not just being pulled by something we can't see clearly because of dust. Some researchers believe part of what we're measuring may be influenced by mass structures beyond the cosmic horizon, beyond the boundary of what light has had time to reach us from since the universe began. Not hidden. Not disguised. Genuinely, physically beyond our ability to ever observe directly, and yet still influencing our motion through gravity, which, unlike light, doesn't need billions of years to make its presence felt at a distance. We have named it. We have mapped its approximate direction. We have partially attributed its pull to Laniakea's total mass. And we are, provably, undeniably, moving toward it, along with everything we can see for hundreds of millions of light-years in every direction. But if you asked me to describe exactly what sits at that center, in full honesty, beyond an enormous concentration of galaxies partially obscured from view, I couldn't finish the sentence with certainty. There is comfort in believing we understand our place in the universe, a stable galaxy, orbiting a stable sun, drifting through calm, empty space. The great attractor quietly reminds us that stable was never the right word. We are moving, at extraordinary speed, towards something vast, largely unseen, only partially explained, and we have been moving toward it for longer than our species has existed, without ever once feeling the motion beneath our feet. That is the strange, humbling nature of gravity. It doesn't need your attention to work on you. Now, for our final mystery, one that isn't a single object, or even a single galaxy, but something written into the very oldest light in existence. Everything we've discussed so far, a signal, a sound, a dimming star, a gravitational pull, is strange, but bounded. Each one sits at a specific place, a specific distance, a specific coordinate we can point a telescope toward. This last one is different. This one is written into the oldest light that exists. In 2004, scientists studying the cosmic microwave background, the faint afterglow of heat left over from roughly 380,000 years after the Big Bang, essentially the oldest baby picture of the universe we will ever have, found a patch of sky unusually, significantly colder than everywhere else around it. They named it, simply and accurately, the CMB cold spot. This isn't a small anomaly. It spans a region roughly 5 degrees across, about 10 times the width of the full moon in our sky, and it registers colder than the statistical models of the early universe predict should be possible, at a level that shouldn't occur by random chance more than once in the entire observable universe, if it occurred at all. Astronomers spent years trying to explain it with something ordinary. A supervoid, an enormous, unusually empty region of space between us and that patch of ancient light, causing the light passing through it to lose a small amount of energy on its journey to us, cooling it slightly by the time it arrives. For a while, this seemed like the tidy answer. Surveys did find a large void in roughly that direction. But later, more precise studies found the void wasn't quite large enough, or quite empty enough, to fully account for the size and depth of the cold spot using our standard models of the universe. The explanation didn't close the case, it only narrowed it. Which leaves the possibilities scientists still discuss, cautiously, in published research, a statistical fluke so rare it stretches the definition of rare. A sign that our models of how matter clumped together in the early universe are subtly, meaningfully incomplete. Or, and this is the version that tends to get the most attention, though it remains firmly speculative, a signature of something happening beyond what we call the observable universe altogether. Some theoretical physicists have proposed it could be evidence of a collision, in the deep past, between our universe and another region of spacetime entirely, a bruise left behind from contact with something we have no other way of detecting. I want to be careful here, because it's tempting to let a phrase like evidence of another universe run away into fiction. Most cosmologists still consider a statistical anomaly or an undermodeled void the more likely explanation. But most likely has an honesty to it that I respect. It means the door hasn't been fully closed, in either direction, on a patch of sky that represents the coldest, oldest, strangest anomaly we've found in the very fabric that everything else, galaxies, stars, black holes, you, me, was eventually built from. So here is where I leave you tonight, with 5 things: a signal that arrived once and never again, a note too vast to be heard, a star that dimmed for reasons we can only partly explain, a pull towards something we cannot see, and a cold patch in the oldest light in existence that might mark the edge of something we don't have a name for. None of these things are certain to be anything more than natural, explainable phenomena that simply haven't finished being explained yet. I want to be honest with you about that, because certainty is easy to sell and hard to earn. But I also think there's a mistake in assuming that probably natural and disturbing are opposites. Sometimes the most unsettling truth isn't that something otherworldly is out there. It's that the universe is vast and old and strange enough to produce mysteries this deep using nothing but ordinary physics, and that we, standing on a small stable planet, orbiting a small stable star, are only just now developing the tools to notice how much of the dark we still don't understand. I am Cosmic Wanderer. I have watched this dark for longer than you can imagine, and I promise you, it still surprises me. Until next time, keep looking up. The universe is not finished whispering.